All right, so whenever you're multiplying two terms together, and the result is 0, that's because one of the terms at least had to be 0. So for example, if I were to multiply 3 times a number and my result is 0, then that mystery number must have been 0. That's the essence of the zero product property. All right, I'm going to talk a little quieter so that we can listen a little better. So in today's lesson, besides learning the zero product property, that when you multiply two things together, one of the terms had to be 0, we're also going to talk about some vocabulary words. When you are told to solve an equation, that means your problem had an equal sign in it, correct?
Yes.
When I ask for the solutions to an equation, I'm now going to use some other words interchangeably with the word solution. If I ask you to find the roots, it means the same as the solutions. If I ask you to find the zeros, it means find the solutions. If I say find the x-intercepts, it means find the solutions. Now I'm going to talk to you a little more about zeros and x-intercepts when we start graphing our polynomial equations. But for now, I want you please to realize that those are all synonymous, okay? That if I say find the roots, I really mean solve it. If I say find the zeros, it means to solve it, etc. So in number 1, we have two binomials, and they are add, subtract, multiply, or dividing each other.
They're
Multiplying. So if x plus 6 and x plus 1 are my terms, and we're multiplying them together, for the result to be 0, then it means one of them had to be 0. So what you're going to do is you're going to take each factor, set them equal to 0, solve them separately, and get two answers. So when I said x minus 6 equals 0, I add 6 to each side. We get one answer of x equals 6. David, what's my other answer? Good. Can you follow along with me, please? And we'll have two answers. So this is what we're going to do. You can circle that like that. You could write x equals 6 or negative 1 like that. When I was in Algebra 1, my teacher told me to write it like this. You draw little brackets, and this would be called the answer set or solution set. So at Harvard-Westlake in our math department, the algebra teachers are mostly doing x equals or x equals this or that. So you don't need to do the brackets, but if you ever see the brackets, it means the solution set.
We're allowed to do the brackets.
It doesn't matter to me, but if you go on to your next year's class and the teacher's like, I don't want you to use brackets, then know that that's what they wanted you to do. Okay. So let's go ahead and do the same thing for B. Set each factor equal to 0. And solve them separately. Meyerson, can you tell me what the first answer will be?
Yeah. The first answer would be negative 1.5.
Can you tell me it's an improper fraction?
Oh, is it improper fraction?
Please.
3 over 2.
Negative 3 over 2. Good. You know what? And I didn't show my work there because you guys are at the point at this point you should not have to go minus 3, divide 2, divide 2. If you want to, you may. But the hope is at this point in Algebra 1, you can save some time by not having to show that much work. And then your other solution you get to be positive 8.
Yeah.
Okay. So besides the zero product property today, we're going to learn to take the greatest common factor of a polynomial. So in problems like number 2, you're going to look for the greatest common factor, otherwise known as the GCF, that will divide evenly to each term. When I teach this, I always think the word undistribute. So for example, if I said, will you please multiply 3 times x plus 2, what would that work out to be?
3x plus 6.
Jordan.
3x plus 6.
What did you do to get that?
I would distribute it.
You distributed. All right, now what if I said, look at 3x plus 6 and tell me what the greatest common factor is? What will go into 3x and what will go into 6? Al? 3. So we put the 3 on the outside. Ask yourself, what times 3 is 3x? 3 times x is 3x. And 3 times what is 6? 2. So we kind of have this cycle. We have, when we're multiplying, we call it distributive. And when we're factoring, in this case, we call that the GCF, or we call it factoring. So you really have to pay attention to the directions so you know what you're doing. So in number 2, look at the directions. It says factor out the greatest monomial factor. Ask yourself, what number goes into 12 and into 42? Good. Put 6 on the outside, put a set of parentheses. Now after you have the 6 on the outside, you're thinking division. Alex?
6 parentheses 2x
Plus
7y.
Plus 7y. Good. So Alex said, well, 6 times 2x is 12x. And Greg, she said 6 times 7y is 42y. Now, what stops her from redistributing the 6? She read the directions, and it said to factor, so stop. This is your answer. All right, Andrew. Please. 4x to the 2? 3? Yes, you should. Because in this case, not only are 4 and 24 both divisible by 4, but x to the 4th and x to the 3rd are both divisible by x to the 3rd. For example, if I have x to the 4th, that's equal to x times x times x times x, correct?
Yeah.
And x to the 3rd, that's equal to x times x times x. So they both at least have x to the 3rd. Andrew, finish that up for me. So so this is x and this is plus 6. So you say to yourself, what times 4x to the 3rd is 4x to the 4th? Well, times x. What times 4x to the 3rd is 24x to the 3rd? 6. That's where you're stopping because the directions said to factor. Questions so far?
Can I go to the letter class?
If you think this is a time you need to go, then you may go. All right, in number 3, we're going to put both concepts together. All right? First, you need to take the greatest common factor. Second, you need to use the zero product property. That is for number 3. Okay, so my first step is to find the greatest common factor. Notice the directions changed. It said solve and there's an equal sign. But we're still going to find the greatest common factor first. David, what's the greatest common factor?
The greatest common factor is 2x.
2x. So put the 2x down, put a set of parentheses, put your equals 0. Alex?
What is that second step? Does that say zero production property?
You can put production property, but product property is what we learned. But yes, I didn't spell it out. I was trying to abbreviate. Okay, go ahead, Jordan.
And then say x plus 4.
Perfect. So you ask yourself, 2x times what is 2x squared, and 2x times what is 8x? Well, now because we're putting two concepts together, look back up to number 1, and when we had it written out as two factors multiplying, we separated them and set them each equal to 0. So do the same thing. Put your line, say 2x equals 0, and x plus 4 equals 0. You're still going to get 2 answers, but obviously when you divide each side by 2 here, you're going to get x equals 0, minus 4, and x equals negative 4. Ryan.
So to get the number 1, you have to get a parentheses then?
Yes. So Ryan, if we want to have parentheses for b, if we want to make it a product, what does 3x squared and 27x have in common? Let's see, what does 3 and 27 have in common? What will go into 3 and into 27? 3. Good. What will go into x squared and go into x? Good. Now you're going to come up with your 9. So now, Ryan, ask yourself, 3x times what is 3x squared?
X.
Perfect. And 3x times what is 27? X.
Minus 9.
Minus 9. And you're careful to carry down the correct sign. Good. Draw your line. 3x equals 0. X minus 9 is 0. Leslie, what are my two solutions?
X equals 0.
And?
X equals 9.
Perfect. All right. Number 4 looks a bit different. What do you think we have to do for number 4? Andrew? What? Oh, that's what you said. I prefer subtracting the 15 in. It's good to keep the squared term positive. So you want to make the 6n squared. Good. So yes, to use the zero product property, you must write the equation so that one side is 0. So now it looks like ones we did in number 3, correct?
Yeah.
Correct. All right, David, what does 6n and 15, or 6n squared and 15n have in common?
They share 3n.
They do share 3n. Let's go ahead and factor it.
That's 2n.
2n minus 5. Now, because the direction said to solve, we need to use the zero product property. And Ilana, what do you have for your final answers?
N equals 0.
And? Or rather? And the next one?
N equals 2.
Oh, I'm sorry. You're saying it. Yes. I tend to leave all my answers improper. Yes. 2.5 or 5 halves is fine. All right. Craig, you need to get caught up on your notes. Are you okay? Okay. Go ahead and turn it over. On the back side is your classwork for today. When you finish, you can start your